right, 80s and receiving students, in today's lesson, we are going to look at the volume of a cone. All right? Okay. Now you all know what a cone looks like, okay? And you can, receiving students and 80s, you can name examples. You can name examples of cone shapes or shapes that come in a form of a cone. What is one example of a, okay, an ice cream cone, yes, that comes in the shape of this solid cone. All right. Now I'd like you to look at these two solids, all right? These two solid shapes, okay? What is this solid shape? A pyramid, okay? 8Es and receiving students. A pyramid, okay? What's this? A cone, okay? So we have a pyramid and a cone. Now, if you look closely at these two solid shapes, okay, class, list down any properties that these two solids have in common. Okay, look closely or look carefully at these two solids. Receiving students, list down any properties that these two solids have in common. Okay, one. Sorry. Can we have John, your group, please, quickly? Just list down anything that is same about these two solids. Any properties that these two solids have in common. Okay, I said one from John's group, please. List one property.
The apex.
Oh, apex. What about the apex?
The sharp point of the cone and the triangle.
Okay, sharp point. Only one has it?
Cone two. Both.
Both. Okay, thank you, Malcolm. Okay, Malcolm is trying to say that these two solids, okay, they both have an apex. Yes? Okay, that's one property that these two have in common. They both have an apex, you see? You can say an apex or a vertex. Can be called a vertex or an apex. Receiving students, see the pyramid has a sharp point, also the cone. Okay, any other properties that they have in common? Fiona? Okay, Fiona?
The same height.
Same height. Do they have same height? Thank you, Fiona. Okay. Fiona said same height. That means both these two cones, they both have the same height. Okay. Now, if I put them together, you see, this one is higher than this. Okay, good. Livingston? Receiving students, please tell the class some of the properties that these two solids have in common.
The two items have the same base.
They have the same base? Okay, they have a base. Okay, these two solids, they have a base, you see? The pyramid has a base. The cone also has a base. Okay, they both have bases. Good. Okay, can we go back to the height? Okay, yes, they have heights. Today, they have heights. Okay, good. So those are some properties that these two solids have, okay, in common. They have a height, they have a base, and they also have an apex or vertex. All right. Anything different about these two solids? Receiving students, list down any properties that these two solids don't have in common. Class? Abby?
The bases.
Okay.
The cone has a circular base and the pyramid has a square base.
Okay, very good, Abby. Okay, she said that the cone, the bases are different, okay, with these two solids. You see, the cone has a circular base, all right, and the pyramid here has a square base. Okay, a pyramid can have a square base or it can have a rectangular base, okay? Square base or a rectangular base. Okay, good. Anything else? Okay, maybe, yes, Roseanne.
A cone has a curved side and a pyramid has a triangular side.
Okay, thank you. All right. The cone has a curved surface, all right, whereas the pyramid has triangular faces, okay, whereas the cone has only one curved surface or curved face. Okay, good. So those are some of the properties that these two solids have in common. We looked at some of the similarities and some of the differences. Okay. Any solid that has an apex with a different base, any different base, the formula will always involve or will include 1/3, okay? 80s and receiving students, are you listening? Okay, I'll come again. Any solid, all right, any solid shape or solid that has an apex, all right, will always, the formula will always start off with 1/3. For example, if you look at the volume of the pyramid, the volume starts off with 1/3 because of the apex. Okay, who can tell us what is the volume of a cone? Receiving students and 80s. Receiving students, what is the volume of a cone? Okay, let's have Ella.
Volume equals 1/3 times. Volume equals 1/3 times area times height equals to 1/3 times pi r square height.
Okay, thank you, Ella. All right. Volume is equal to 1/3 pi r squared h, or volume is equal to 1/3 times pi r squared times the height. Why is it pi r squared, receiving students and 80s? Why do we have pi r squared there? Who can tell me what is pi r squared? Looking at that formula of a cone, receiving students. Now I reminded you that any solid that has an apex starts off with 1/3, okay? Now if you look closely, 1/3, and why pi r squared? We're looking at the cone. Receiving students, please tell the class why pi r squared? Where does that pi r squared come from? Why is it there in that formula? Yes? Okay, Korai. We'll have Korai to tell us.
It comes from the radius.
Sorry?
It comes from the radius.
From the radius. Okay, thank you, Korai. And where does the radius come from? Okay, I want someone to tell us, please. Okay, Winnie. Receiving students?
From the base,
What base?
the cone base,
The cone base.
safe.
The cone base. Okay, the cone, thank you, Winnie. The cone has a what base? Okay, the cone has a circular base. Okay, receiving students in 80s? The cone has a circular base. So we are trying to look for the area of the what? Circle. And area of the circle is equal to pi r squared. So you see, that's why we have pi r squared, because it's an area of a circle. The base is a circle. So receiving students, that's why we have volume is equal to 1/3 pi r squared, which is the area of the base, circular base, times the height. Okay, good. So likewise with the pyramid, because it has an apex, volume is equal to 1/3 times area times the height. The area of the base, with a rectangular base, length times width times height. Okay, thank you 80s and receiving students. Let's just go through this together, all right? This example together, okay? Receiving students and 80s. Now, here we have a cone in a cylinder, okay? A cone in the cylinder. One thing about the cone in the cylinder, the bases are the same, okay? The bases are the same. What about the height? Is it also the same? Yes, okay. The height of the cylinder is also the same as the height of the cone. All right. So the radius is 7 centimeters. The height is 10 centimeters. Okay, so we'll go through this together, okay? So using the formula, volume is equal to 1/3 pi r squared times the height. So here 1/3 times pi r squared, 3.14, times the radius is 7, okay? So 7 times 10 is the height, yes? 10 is the height. So when we calculate this, we came up with 512.87. And the volume of the cone is 512.87 cubic centimeters. Okay, that's just an example, but I'm going to give you your activity now, okay? So you can work on your activity. So here I have 3 activities, class. Calculate the volume of the cones. I have 3 activities, A, B, and C. So can you copy this one down quickly before you start? Okay, maybe you can just get down the measurements, okay? Instead of drawing the whole cone, just get the measurement, the radius and the height. Okay, receiving students, this is your activity. Okay, you finished with A. Like I said, receiving students, just get down the readings of the measurement. Okay, B, copy down B. The radius is 4 centimeters and the height is 21 centimeters. Okay, that's for B. All right, C. C, the diameter is 7 centimeters and the height is 17 centimeters. Okay, we should not waste time. Let's start, please. Okay, remember you're using the formula. Using the formula, volume is equal to 1/3 pi r squared h. Okay, I want you to work with your friend, work in pairs. If your friend needs any help, please help your friend. Okay, I said only 3, A, B, and C. Okay, have you finished with A? Yes? Okay, good. right, what we'll do is 80s and receiving students, we'll go through activity 1 or A, and if you haven't finished with B and C, you can complete that for your homework, okay? And maybe we can go through the 2 activities in our next lesson, but for now, we'll just go through activity A, okay, receiving teachers. Maybe in your own time you can correct B and C with your class. All right, let's look at A. Okay, who's got an answer for A? Receiving students? Okay, who came up with an answer? Okay. Receiving students and 80s, I'll just write up the formula. Okay, volume is equal to 1/3 pi r squared h. Okay, then we have 1/3 times what? 3.14 times, okay, 3 times 3 times 23. Okay, good. And then, okay, we have to multiply 3.14 times 3 times 3 times 23. So firstly, we multiply 3.14 times 3 times 3. So what's our answer? 3.14 times 9 is 28.26 times 23. Okay. And what's our answer? 649.98. Okay. And then what do we do? Divide by 3. Okay. 649.98 divided by 3. What's our answer? 216.66 cubic centimeters. That's the volume of the cone. Okay, 80s and receiving students. This is our answer, final answer. All right, we'll stop here, 80s and receiving students. Like I said, receiving teachers, B and C, the students can do for their homework. And maybe in our next lesson, we'll just correct the other 2 activities. Okay, thank you, class. Our key phrase, receiving teachers, volume of a cone. Okay, thank you, 80s and receiving students, for your participation in today's lesson.